Okay, so let's do an example on a thin pair share where we use right triangle geometry to determine six trigonometric ratios or functions. So given the following right triangle illustration with side AB being equal to 5, side BC being equal to 3, and side AC being equal to 4. And the angle of interest. So this is our angle of interest. So you can see opposite the angle of interest gives us the opposite side. The side adjacent to our angle of interest is the adjacent side. And then the side opposite the right angle, that's the hypotenuse. Okay, so now we want all six trig functions. So let's first find the sine of our angle of interest. So you can put in SOHCAHTOA, sometimes that helps. And so we can see here that sine is equal to opposite over hypotenuse. So opposite over hypotenuse, which is equal to y over r. And so the value of y is 3, and the value of our hypotenuse is 5. And so 3/5 simplifies to 0.6. So the sine of this angle, we don't know what degrees or radians this is. Okay, and that's okay. But we know the sine of that angle is 0.60. Okay, let's look at cosine. So cosine is adjacent over hypotenuse. So adjacent over hypotenuse. The adjacent side is 4. And the hypotenuse is 5. So 4/5 is 0.80. Now let's look at tangent. So the tangent is equal to the opposite over the adjacent side, opposite over adjacent, okay, which is y over x. And y in this case is 3, which is the length of the opposite side. And the length of the adjacent side, which is the value along the x-axis, that's 4. And 3/4 is equal to 0.75. So the tangent of our angle of interest is 0.75. Now let's look at the reciprocal trig functions. So cosecant is the reciprocal of sine. So we're going to be taking, y over r, we'll be taking 3/5 and then just flipping it, doing the reciprocal. And so the reciprocal of 3/5 is 5/3, or 1.67. So 1.67 is the cosecant of our angle of interest. We can look at the secant of our angle of interest. Still, angle of interest is here, and the secant is the reciprocal of cosine. So again, to take the reciprocal, you just take numerator and denominator, and you flip them. And so instead of 4/5, now we have 5/4, and 5/4 is 1.25. So the secant of our angle of interest is 1.25. And cotangent is the reciprocal of tangent, which means you take numerator and denominator and you flip them, and 4/3 is 1.33. So the cotangent of our angle of interest is 1.33. Now let's say we wanted to know what was the slope of the hypotenuse. What was the slope of the hypotenuse? Well, here's the hypotenuse, and slope is rise over run. And you'll notice that how much we rise is equal to the length of the opposite side. And the amount that we run is the length of the adjacent side. So the tangent of our angle of interest will be the rise over the run. So the slope of the hypotenuse is 0.75. So it's kind of a little bit of a shortcut that you can use tangent theta to get you the slope of a line. And here I already noted this before, but I said the degree measure of theta is still unknown, but relative to theta, you now know all 6 trig ratios. So we did know the length of each side of this right triangle, but we just didn't have any idea what this value of our angle of interest, what it really was. But that was okay. It's still unknown, but at least we know that, for sine, that the ratio of opposite to hypotenuse is 0.6. So we will be able to get the angle from that later. Okay, let's move on to the think, pair, share. So again, this is where I would hand this over to my class. They do, a student-centered activity where they work together and use my previous example as a model. So I would like you to do the same. Go ahead and pause the video now and try this on your own. Okay, so let's try and work this out together. So given a right triangle illustration with AB being equal to 4 and line segment BC being equal to 3 and line segment AC being equal to the square root of 7. And we have our angle of interest. So because our angle of interest is here, this side is going to be the opposite side. This side is going to be the adjacent side. And then the side opposite the right angle, that is the hypotenuse, or the radius of a circle. So determine all 6 trig ratios of the given right triangle. So we're going to do SOHCAHTOA to start. So the sine of our angle of interest is equal to the opposite over the hypotenuse. The opposite is 3. Hypotenuse is 4. So it's 0.75. Let's just leave it as a fraction. We'll leave it as a fraction. Okay, so sine of our angle of interest is 3/4. Now cosine is adjacent over hypotenuse. And the length of the adjacent side is the square root of 7, and the hypotenuse is 4. So cosine theta equals the square root of 7 over 4. Now let's do tangent theta. So tangent is opposite over adjacent. So opposite over adjacent. The opposite side is 3. Adjacent side is the square root of 7. Now, typically, you don't want to leave a square root in the denominator if you ever have a fraction like this. So we'll have to multiply top and bottom by the square root of 7. And that'll make this 3 square root of 7 all over 7. So now we don't have a denominator with a square root in it. Okay, and we want, let's see, all 6 trig ratios. So let's do the reciprocal trig functions next. So the reciprocal to sine is cosecant. And all you need to do is just reverse the numerator and denominator. Okay, the reciprocal of cosine is secant. Switch those. Okay, we can't have a square root in the denominator. So we'll just multiply top and bottom by the square root of 7. And so secant theta is going to be equal to 4 square root of 7 all over 7. And then cotangent theta is going to be the reciprocal of tangent. So I'll use this version of it because that will let us put square root of 7 over 3, and we don't have a square root in the denominator. Okay, and again, to highlight, the slope of our hypotenuse is tangent theta. So the slope is equal to 3 square root of 7 over 7. That's also our slope. Okay, that concludes these two examples. Let me know if you have any questions.